For example, okay, there is mass here. This one is example 1 here. Okay, if a mass given, okay, for example 1 kilogram here, so we can say the object when it start to moving ataupun objek ni bergerak, okay, mass ni bergerak, M1 ni bergerak, so dia akan mengalami momentum. Dia akan ada V kat sini, okay, walaupun dia tak ada acceleration, okay. For example, V dia bergerak, okay, but the acceleration still zero. Apa yang dimaksudkan kat sini, okay. Kalau acceleration dia kosong kat sini, tapi dia bergerak, bermaksud, contoh kat sini 1 meter per second. So, that mean the velocity here is constant. Okay, kalau constant velocity ataupun halaju malar, okay, you akan dapat acceleration dia kosong. Tapi, it's still gaining a momentum. Okay, so momentums given by P lah. Okay, P heads here. This one is represent for vectors, okay, yang berkaitan dengan magnitude and direction. So mass times the velocity, very simple one, okay. So the units here, kilogram meter per second, okay, ataupun kgms negatif 1, dua-dua boleh lah, okay. So this one is the formula, basic formula for momentums. So P, kita boleh kira M dia adalah 1 kilogram kali dengan 1 meter per second. So jawapan dia akan dapat 1 kilogram meter second negatif 1. So momentum dia adalah 1 kilogram meter per second negatif 1. And then next one, okay, we also have discussed on impulse, okay. So impulse, so berkaitan dengan J lah lebih kurang ataupun I lah, okay. If you reading books ataupun buku yang berkaitan, dia lebih kurang kepada I, ada lebih kurang pada J, lebih kurang lah, okay. So as long you know that one is I ataupun J, okay, simple J. So impulse, okay, mostly dia akan berkaitan dengan changes in momentum, okay, changes in momentum, okay. So mostly dia akan pergi pada changes in momentum. Alright, so here melibatkan kepada mass dan juga velocity. So mostly yang berubah ataupun changes in momentum akan melibatkan kepada velocity sahaja, okay. So mass dia tetap sama, okay. So there is changes only on delta V, okay. So mass equivalent to delta V, that means the changes in velocity adalah sama juga dengan V final tolak V initial, okay. So kat sini akan dapat MV tolak MU. This mean is changes in momentum, yang berkaitan dengan perubahan momentum. So, okay, so impulse adalah bermaksud perubahan momentum, okay. So tolak sahajalah. Alright, selain daripada tu, okay, impulse juga, okay, adalah sama juga dengan F kali dengan delta T, okay. So F sama dengan delta T. So kat sini you boleh samakan jugalah, okay. Sama juga dengan delta P ataupun MV ataupun M delta V, okay. So from impulse we can calculate ataupun changes in momentum, you akan perasan kat sini, okay. Newton second law dia akan melibatkan kepada F delta T equivalent to M delta V. So you akan dapat kat sini force adalah sama juga dengan M delta V per delta T, and then F equivalent to M V, perubahan halaju bagi dengan masa, you akan dapat acceleration. So this one is for Newton second law, okay. This one basic dia adalah daripada perubahan momentum ataupun objek yang bergerak. Alright, so few example. For example number 2 here, okay. So impulse equivalent to F delta T changes in times and delta P here ataupun M delta V, okay. So for example here, okay, if an object, okay, so this one is a wall, for example here, okay, then there is a ball, for example a balls, okay. So a balls, okay, hit the walls and return back, okay, in the same direction lah, okay, opposite direction in same axis. This means axis X, for example here. So mass, put here 1 kilogram here. So this one is 1 kilogram. So it took time, okay. When it's hit hits the wall here, okay. So the object will rebounds back, okay. So in this situation, okay, 1 kilogram, still the same mass, okay, still the same object here. So but in difference, what we call it, in difference indifference velocity, for example lah. Okay, kalau indifference velocity, so we can consider here 1 kilogram. So it start hitting with speed u, initial speed, okay, 1 meter per second. Okay, after that it returns ataupun rebounds back. Okay, after hitting the walls, we can consider the value here with the lower speed. Okay, with the lower speed. This means this one is 1 meter per second, and then return backs ataupun rebounds, okay, with 0.5 meter per second. Okay, become slower. Okay, V dia kan, ataupun after rebounds it get 0.5 meter per second here, so it becomes slower. Okay, so from this formula, okay, we can calculate the force, and then if you are given the time taken, okay, kalau time dia, okay, so it hits the wall and this event occurs in 0.05 second, for example. So dia berlaku dalam tempoh letupan ni, okay, explosion ya, okay, hitting the walls in 0.05 second. Then we can measure the force dekat sini, okay. So from here we can calculate the first one, the initial momentum. Initial momentum before hitting the wall. So that's mean U lah, okay. So initial momentum kat sini, P initial equivalent to MU. Okay, so MU sama juga dengan 1 kilogram kali dengan 1 meter per saat sama juga dengan 1 kilogram meter per second here. So after that, we can calculate the P finals, momentum finals, MV finals here. Okay, so mass still the same mass, still steam the object, okay. Same object here, then multiply the V ataupun halaju before U, halaju after, okay, after hitting the walls here is 0.5. So letak sini 0.5. So you get here 0.5 kilogram meter per second here. So dapatlah initial dan final. Okay. Next one, we want to calculate the impulse. Okay. So impulse is referring to the changes in momentum. Maksudnya perubahan momentum before and after. Okay. So we have find yeah. So the impulse is given by delta P. So delta P is equivalent to P finals, okay, minus P initial. Okay. P final 0.5 here. And then minus 1 kilogram here. So dapatlah jawapannya 0.5. Okay. So 0.5 here. Okay. So same using the same units. Okay. So dapatlah 0.5. So this one is the changes in momentum. After that, we want to calculate the force. Okay. Apakah nilai force yang terhasil ketika pelanggaran kat sini? Okay. When it start hitting the walls here. Okay. What happened here? Okay. The force berapa banyak yang berlaku dekat sini in this area. So impulse is equivalent to F delta T equivalent to delta P here. Okay. So you boleh kira lah force dia. So force equivalent to delta P here bagi dengan delta T. Very simple one lah. Okay, 0.5 divide by time taken dekat sini, hittings, elemen hanya berlaku dalam tempoh masa 0.05 second. Terlalu pantas. Okay, so very fast. So here, 50 divided by 5, then you get 10 newtons. Okay, you akan dapat 10 newton. So this one is very basic, common for impulse and changes in momentum. Okay. So kena ambil tahulah kat situ yang berkaitan dengan changes in momentum dan juga how to calculate the average force, okay, daya yang dikenakan pada kita panggil sebagai pelanggaran, okay, ataupun collision. Okay, other than that, okay, ada examples for impulse, okay. So impulse is equivalent to F delta T equivalent to changes in momentum. Right, so here, for example, there is a ball here, okay, and then most of the student here is very like playing football ataupun soccer lah, okay. So what happened here, okay, so it kicks the ball. Ya, ada soalan apa?
Yang tadi kos bukan negatif 0.5 ke?
Ya betul, sorry. Thank you for your correction. Okay, so kat sini dapat negatif Okay, 0.5 darab 1. Okay, terima kasih. Okay, so ada negatif kat sini. Okay, terima kasih Farah. Okay, and then ada any other question? Tak ada. Kalau tak ada kita continue lah. Okay, sorry for the sign tadi. Okay, terima kasih untuk ingatkan saya. So somebody is hit the balls. Okay, playing a balls. Yeah. Okay, so what happened here? So it will explode. Maksudnya akan ada berlaku letupan. Okay, in term of biasanya sound. Okay, dia akan melibatkan sound ataupun bunyi ataupun reaction. Then what happened to the balls? So the ball will start to move here. Okay, so M1 sini. Okay, so same things. Okay, if the ball is moving with the speed of 5 meter per second after hit by a person ataupun kick by the person lah. Okay, so you akan calculate dia punya changes in momentum. Okay, P initial ataupun momentum initial dia MU sama juga dengan berapa? Kalau mass dia kat sini saya letaklah berat sangat bola ni, 0.5 kilogram. Okay, so 0.5 initial speed dia kosong sebab dia stationary. Okay, 0.5 kali dengan kosong dapatlah kosong. Still tak ada. Alright, so equivalent to 0. Then P finals. Okay, P finals dia. Okay, momentum final dia MV kat sini. So equivalent to 0.5 kilogram multiply by the speed here. 5 kat sini you akan dapat 0.25 kilogram meter per second. Okay, 0.5. Salah pula jawapan kat sini. Okay, 0.5 equivalents to, this one should be 2.5. Sorry, this one should be 2.5. Okay, 0.5. 2.5 ya. Okay, so changes in momentum, final minus initial. Okay, changes in momentum equivalent to 2.5 minus 0. Then you still get 2.5 kilogram meter per second here for changes in momentum. Then we can calculate if the event ataupun situation ni occurs in time, within the time frames of, okay, 0.05 second. Ambil lah 0.50 second. So we can calculate the average force apply. So kat sini delta P changes in momentum is equivalent also with the impulse. Okay, before that, okay, changes in momentum sama juga dengan impulse ataupun dia punya pulse, denyut dia. Okay, so the average force, okay, equivalent to, okay, force sama juga dengan delta P changes in momentum divide by changes, sorry, the time taken here. Okay, so 2.5 divide by 0.05. So how much here? 250 divided by 5, then equivalent to 50. Okay, 50 Newton. So the force occur here is equivalent to 50 Newton. Okay, for the balls to move 5 meter per second. Ini kaedah dia lah. So the force, okay, from the leg here, okay, by the kicking here is 50 Newtons equivalent, in equivalent. Alright. So example 3, we go for example 3, reference for momentums, okay, in two-dimensional, yang melibatkan kepada two-dimensional. For example here, given the situation, okay, next one here, okay, so there is angle here. So bila ada angles, dia melibatkan two-dimensional ataupun dia akan melibatkan X dan Y. Okay, situation two-dimensional. So it occur with X component dan juga Y components. Okay, so this given to you here is a ping pong ball. Okay, 0.7 gram here, moving initial. This one is final, before and after juga lah. Okay, so this one is 35 degrees. This one is given to you 25 degrees. For example, the situation here. Okay, moving at 5.2 meter per second here. Okay, 5.2 meter per second for the initial speed here. 5.2. Next one for the V here given to you. Okay, 4.7. Okay, 4.7 meter per second here. Okay, so kat sini ada 2.7 gram. Okay, hal laju awal dia 5.2, hal laju akhir dia 4.7. Okay, very simple one. Then we can calculate, okay. Determine the magnitude and direction of impulse exerted by the ball, okay, by the table to the ball, okay. So initial speed dia berapa dengan final speed dia berapa, so you can calculate lah, okay. This one, since this one is moving in angle, okay, so dia akan ada position yang mana kat sini akan ada ux, uy dan juga ux. So dia akan ada dua pecahan, okay. X komponen dengan Y komponen. Sudut kat sini adalah 35. Okay. Kalau 35, sudut atas ni pun 35. Okay. So here, you can calculate the angle here. Sebab apa? Dia bergerak ke sini. Contoh dia, ni 35. Setentang, okay. Opposite dia pun still 35 darjah juga. Okay. So ux kat sini. So you can calculate lah, okay, initial speed dengan final speed dia. Okay, untuk ux sama juga dengan v dia 5.2 cos 35 darjah, and then uy sama juga dengan 5.2 sin 35 darjah. Okay, then you akan dapat dua lah jawapan kat sini. And then for the same thing for the final, okay, so for final velocity there is a Vx, okay, this one is Vy. Okay, angle here 25 degrees. Okay, same Vx equivalent to 4.7 cos 25 degrees, and then Vy equivalent to 4.7 sin 25 degrees. Then you have here, okay, Ux dengan Uy. Okay, then you can calculate lah. Okay, untuk changes in momentum, the basic one is using vectors. Okay, you boleh gunakan vectors, but this one is different since there is two components, ada x dengan y, so you gonna buat x dengan x, y dengan y. Okay, so changes in momentum, that means the impulse. Okay, impulse for x component ataupun changes in momentum for x component. So x component melibatkan ux dengan vx kat sini. So you kena tolak kat sini lah. Okay. So since the mass here, mass ping pong ball 2.7 gram here, mass multiply by changes in momentum, changes in velocity. So v dia, okay, vx tolak ux. So kat sini akan ada vx tolak ux. Okay, vx tolak ux. So kat sini 2.7 grams. Then you have to change to kilogram in SI unit. Okay, juga kepada SI unit, you akan dapat 2.7 kali dengan 10 negatif 3 kilogram. Okay, sebabkan 1000 gram sama juga dengan 1 kilogram. Okay, this one is basic lah. Okay, kat mana-mana pun mesti tahulah 1 kilogram sama dengan 1000 gram. Okay, 1 gram bersamaan dengan 0.001 kilogram. Alright. So mass 2.7 multiply 10 to the power of minus 3. Then here Vx tolak Ux. So ambil kat sini Vx dengan Ux. You dapat jawapan kat sini. Okay, then you boleh calculate lah. Okay, yang berkaitan kat sini. So 4.2 minus 4.26 minus 4.26. So jawapan dia kosong. Okay. So you get some zero lah. Zero answer for this one. Okay. For UX. Okay. Next one. JY. So JY. M. VX. Minus UX ya. So same thing. Okay. 2.7. 10 to the power of minus 3 ya. Multiply by Vx, Ux. So Vx sini, Vy sini. Sorry, this one is Vy, Ui. Okay, yang melibatkan Y. Okay, so you akan dapat jawapan 1.99 plus minus 2.98 here. Then you should get the answer here equivalent to 0.013 kilogram meter per second. Okay, so jawapan dekat situ. Okay, so this one is the changes. So Jx ataupun impuls pada X sama dengan kosong, impuls pada Y direction sama dengan 0,013. Right? So then you can calculate dia punya apa? Force. Okay, delta T. Okay. Sorry, changes in momentum ataupun impulse. Okay. Write down. Okay. Impulse is given by changes in momentum. F delta T equivalent to changes in momentum. Okay, ataupun M delta V here. Okay, then you can calculate the force lah. So the force only occurs dekat mana? Since Jx sama dengan kosong, then you tak akan dapat jawapan lah. So the impulse only happen in Y direction sahaja. Okay, so the force acting is equivalent to Fy. Okay, yang melibatkan daripada Fy. Okay, so Fy equivalent to delta Py, okay, divided by delta T. Okay, if the time taken when hitting the floor here, okay, the time taken delta T is 0.05 second, for example, then you can calculate here. Change the color. So we can change color here. 0.013 divided by 0.05. Then you should get 0.26 Newton for the answer. Okay. So force apply in this situation, okay, dekat kawasan ni adalah 0.26 Newton. Okay. Contoh lain. Okay. Other than that, you can calculate the time taken. Okay, application for real life. Example berapa dah? Example 4. Okay. In real life situation, okay, momentums, okay, untuk jurutera, okay, when there is a traffic light here, okay, right, so there is traffic light here, so there is a distance here, okay, so distance, there is a car here, okay, car here, Lamborghini, new model, okay, this one is a new model for Lamborghinis, okay. Alright, so the weight of the car given mass even roughly using 1000 kilogram. Okay, mass dia adalah lebih kurang 1000 kilogram. Okay, so what happened here? Okay, the red light is light up. Okay, so there's a red light here. Okay, red light. Okay, what happened here? So the driver should hit the brakes, right? So should hit the brakes. Okay, situation ya. Okay. Macam mana nak reduce dia punya momentum? Okay, we have done here. Impulse is equivalent to F delta T equivalent to mass delta V here. Okay, so this one is the basic one. Okay, impulse F delta T, M delta V ataupun changes in momentum. Okay, so changes in momentum. Okay, how to reduce the momentum? Okay, so you can reduce the momentum based on this formula. Okay, and changes in momentum. If the car is moving with 50 kilograms, not kilogram here. Okay, 50 kilometer sejam. 50 kilometer per hour, the speed for the car here. Okay, and then red light here. Okay, what are the difference? If the car stop at first position and then second position here, okay, A and B. Okay, and the what we call here, the distance between the traffic light here, okay, is 5 meter, and then is 5 meter. Put here. Better put here. 2 meter. This one is also 2 meters. Okay, right. So you can figure out, okay, which one is the best to reduce the momentum. Okay, so dalam situasi ni, okay, the time taken A and B. Okay, so how much we should step ataupun hit the brakes at the A or B? Ada jawapan? Situasi nak brake dekat A ataupun B kalau dah jumpa red light? Tak ada siapa-siapa kat sini nak jawab. A. Why A?
B.
Okay. Kenapa A? Kenapa A kat sini? Why A? Why must the distance here kena pakai A bukan B? Rasa-rasa? Boleh type jawapan, tak ada masalah kat sini. Okay. Selain daripada A, ada jawapan lain? Kenapa tak B? Nobody here? Rasa ramai dekat sini. Dia tengah main PUBG. Tak ada. Nobody? Choose B. Why choose B? Okay. Why you choose A? Why you choose B? When T reduce, P also reduce. Hakim. When T reduce, P also reduce. Okay, T reduce. Kenapa T dia reduce? Kalau dia ambil A, masa yang dia nak sampai tu jauh. Okay, masa dia makin panjang. Okay. Delta TA dengan delta TB. This one is the distance for delta TB. This one is distance for delta TA. Delta TA. Okay, jarak dia berbeza kat sini. Ada dua jarak kat sini. Okay. Based on the formula given here, okay, you boleh calculate. Okay, force delta T changes in momentum. Okay, so changes in momentum. Delta V dia kena berapa? Okay, this one is U. Okay, initial speed. This one is V. Okay, final speed. Final speed dia mesti sama juga dengan kosong. Okay, kilometer per hour. Maksudnya dia braking. Okay, braking distance. This one U dia adalah 50 km per hour. Okay, change to kilometer per second. So nak change 50 km per hour kali dengan H ini bahagi dengan 3,600 second. Okay. Alright, so kilometer here, and then this one is 1,000. Okay. 50,000 divided by 3,600, then you should get meter per second here. Nobody want to take parts for this one? Ramai-ramai ni ada A dengan B je. 50,000 divided by 3,600, you should get is it really, Hakim? 138? 50,000 divided by 3,600. 13.88. Thank you. So jawapannya adalah 13.88. Okay, meter per saat. So make sure lah. Ataupun you boleh gunakan 13.89 dekat situ. Alright. So this one is initial speed. This one is final speed. Okay. So the changes of momentum automatically kita akan dapat lah. Okay. So changes in momentum. Okay. Here is mass times delta V here. Okay. 1,000 multiply by delta V here. V dia kosong. Kosong tolak 13.88. So negative 13.88. Okay. So 13,880. Okay. Kilogram meter per second here. Letaklah negatif. Okay. Disebabkan kosong tolak negatif 13.88 kat sini. So negatif jadi changes in momentum dia braking lah. Ataupun dia bergerak arah bertentangan kat sini. So kat sini akan ada F delta T here. Impulse F delta T. Okay. Somebody choose A. Somebody choose B. So you can see here there's a changes. There's a difference between delta B dan dekat delta TA. Okay. Delta TA jarak dia 4 meter, delta TB jarak dia 2 meter. So delta TA jarak dia adalah 4 meter kat sini. Okay, 4 meter, delta TB 2 meter. Alright, so Vishnu Prakash, alright, 13.87, Farisa 13.88, alright. So kat sini, F delta T, so you can apply the formula here. Okay, so force acting, okay, for the time taken, okay, equivalent to delta P divided by delta T. Okay, so if somebody choose for delta A here, okay, the position A here, so the time taken is much more longer compared to delta TB. Okay, sebab jarak dia jauh, delta TA lebih lama. Okay, if you put here delta TA, what happen to the answer? Okay, compare to delta TB. Okay, so you akan dapat jawapan for delta TA. Okay, the force that you get is much lower compared to the delta TB. Okay, boleh faham ke tak boleh faham? Okay, so F delta P divided by delta TB here. Okay, since delta TB is smaller compared to delta TA, we consider, for example, saya letak kat sini masa dia. Okay, so masa dia kita tukarlah. Kat sini 2 meter, 2 meter, kita tukar pada sini jadi 2 saat, sini jadi 4 saat. Okay, so bila kat sini kita letak pada 2 saat, okay, so jawapan dia akan jadi force ni makin tinggi. Okay, so force A and then force B is less compared to force A kat sini. Okay, so force, okay, from the car, okay, due to TA is much less compared to the force for the TB. Okay, so tu jawapan dia lah. Okay, kalau kita break pada kedudukan TA, masa yang digunakan adalah lebih lama dan daya yang dihasilkan adalah lebih sedikit. Maksudnya force dia lebih kuat. Ataupun kalau kita braking, kalau jumpa traffic light, so kalau ada jarak yang panjang, kita akan tekan brake tu slowly. Maksudnya force apply tu lebih perlahan compare dengan suddenly brake pada point B, yang maksudnya kita kena brake harder. Maksudnya force tu lebih tinggi. Okay, so kat sini konsep untuk, okay, to reduce the impulse, okay, okay, reduce impulse, bukan reduce impulse lah, reduce the force, okay, experienced by the driver and the passenger. Okay, so dalam kes yang lain, okay, yang ni boleh faham ya. So boleh dapat tak saya punya analogy dia. Okay, the longer, the greater distance, the longer the time, so the lower the force. Maksudnya dengan masa yang panjang, force dia kita dapat kurangkan. Okay, ni when happens to the situation of accident lah. Okay, example 5 here. Okay, when there's an accident occurs, collision occurs, for example, car to car here. There's a 2 car here, car A, car B. Then this one is sport car. Okay, alright, so ada car A dengan car B kat sini. Okay, A and B. Right, so what happen here when it collide ataupun dia berlanggar, okay, suddenly there's a what we call collision occurs. Okay, car A hit the car B since the car B is stopping. Okay, right, so what happened here? Okay, so there is a distance between the front of the car touching to the bonnet. That means when the car A start to touch car B, so we can consider the time taken lah. Okay, so kat sini akan ada, kita panggil sebagai buffer zone, bukan buffer zone. Mostly kat depan ni akan ada bumper. Okay, so akan ada bumper ataupun kita panggil sebagai crumple zone. Okay, so crumple zone ni penting untuk apa? To reduce the time taken. Okay, if the time taken become longer, okay, bila ada time taken become longer, what happen to the force? So the force become much less compared to the passenger or the driver. So kat sini akan ada crumple zone. So masa pelanggaran kita panjangkan, we extend the time for the collision. So what happen here? The force due to the collision, kalau ada passenger kat sini, alright, so it experience, okay, changes in force kat sini. Force yang ada, inertia ni ditukarkan kepada suddenly become stop. So the force must be lower. Okay, due to what? Okay, the time taken become longer. Okay, disebabkan dekat situ. Okay, dalam kes kenderaan yang baru, okay, crumple zone dia adalah penting. Okay, so structure kena kukuh, it should be rigid, okay, for the structure of the car, but at the end, rear end, the front end kat sini, dia akan ada crumple zone. Sebab apa? Okay, when it hits, okay, by other cars, it will extend the time of the collision. Okay, kalau time of the collision kita panjangkan, so what happen? The force, okay, experienced by the driver become less. Okay, sama juga dengan driver yang depan. Okay, so this one is impuls, right? So we continue. Tak ada soalan? Tak ada soalan lah. Kalau tak ada soalan, no. Okay, car A 1000 kilograms. Okay, car B is 1000 kilograms. Next one, A and B is here. Okay, different model but same mass here. And then car B speed here adalah stop. That means stationary lah, stopping. For example, there is a traffic light here. Okay, suddenly there is a car A hitting car B. Okay, the speed of the car, okay, 50 kilogram lagi, 50 kilometer per hour. Okay, 50 kilometer per hour here. Okay, so 50 kilometer per hour, okay, hit the car B. So how much the force? Okay, so how much the force? Okay, if the time for the collision, okay, if the crumple zone here, delta T and delta T here, kita dah panjangkan. Okay, so delta T here, the event occurs in 0.05 second. Okay, okay, 0.05 second. Okay, so how much the force? So we can calculate the force. F sama juga dengan changes in momentum divide by time here. So force dia experienced by the driver, okay, delta P here 50 km per hour, okay, 13,880 kg meter per second ya, divide by delta time 0.05 second. Okay, so jawapan dia sampai mega, terlalu tinggi. Okay, so in 0.05 second, okay, ni terlalu cepat lah. Okay, kita letaklah sini. Okay, 0.5 second, lambat sikit. Okay, 0.5 second. Okay, so then you should get the force acting, okay, to the passenger, okay, experienced by the passenger and the drivers. Half of it, that means the force sama juga dengan 13,814 lebih kurang 7,000 Newton. Okay, lebih kurang 7,000 Newton experienced by the passenger, ataupun lebih kurang 700 kilogram beban dikenakan pada passenger tersebut. Okay, so that's why the engineer create airbag, okay, and then the buffer ataupun crumple zone untuk kereta. Okay, the greater the time taken for the event ataupun time taken for the collision, so the lower the force experienced by the passenger and the driver of both car, kedua-duanya. Okay.